let's go ahead and make a new patch, file new patcher, and well, first of all, was anybody not here last week? I think you weren't. Okay. Did you have a chance to look at the tutorials?
No.
No. Okay. That's all right. We'll be able to struggle through here. Great. So make a new patch, file save as, and name it class 2.1. Okay. And this, we're not going to build this. I just wanted to, this is something I put together. This is stuff I forgot last week. Actually, that had a sound effect, but I don't know why it's not working. Maybe it's on the wrong output. Oh well, it doesn't matter anyway. It was making, it's supposed to make typewriter sounds. Anyway, so actually this was a patch from last year. Last year I forgot to do comments. I didn't forget this last week, but it's not bad to revisit this. Comments, it's really important to comment your code. As I said, you can, the shortcut for comments is to type a C, and that will by default give you this blank comment box, and you can type whatever you want. This is a comment. Go ahead and just type a couple comments on your patch. And then also let's make another comment now. And this is a bubble comment. And now to make this actually into a bubble comment like this one over here, what you have to do is go into inspector for that object and change its parameters. All objects have different, all objects in Max have at least one, usually more than that, parameters to it. And you can get to those parameters by doing a command I or view inspector. Or object inspector, rather. Command I. And then it opens up this little side window called the inspector, or in this case, the comment inspector, because I have a comment highlighted. From here, I can click on this where it says bubble. I can click a checkbox to turn that into a bubble. You can also change where the bubble's point is to be on, right by default it's on the left. You can make it on the bottom or the top or the right. And also with the, you can change where that bubble, where that point of that bubble is. Here's a little patch that I created that makes the bubble point move. As you can see, this is the attribute bubble point. And actually, if you look at the attributes in the inspector, if you click right here on this little @ symbol, so it says show attribute names. It will tell you the name of the attribute over here. So this is bubble point. And if I sent it a message that said bubble point with a float value between 0 and 1, it will put that it'll put that point at various positions on the comment. And so right here, what I've actually done is I've used a counter and a little bit of multiplication to create a bubble point message that will move back and forth on this. So I don't know if you guys, if you did the tutorials, you would have seen this multiplication object. We'll go over some math objects today when we start working on the slot machine. But what this is doing is a metro 50 means it's creating bangs separated by 50 milliseconds. And then this counter is counting between 0 and 50. And the 2 right here is changing the mode of the counter to be palindrome. So it goes to the end and then goes back to the beginning, back and forth and back and forth. Then I'm multiplying that by 0.02 to give me a float value. So I have 50 different steps here and I'm multiplying that by 0.02 to give me a float value range of between 0.1 and 0.98 or something. And then I send that into this message, which is a bubble point with a wildcard token. And if you did the tutorials, you would have seen this wildcard token on one of them. But we'll take a look at it again. And what that does, that token gets replaced by the float value coming out of this multiplication object. So this is the message that's getting sent to this comment, which is making its bubble point move back and forth. Completely useless, but it demonstrates a point. Literally a point. Unintended pun there. All right, let's take a look at order of operations. So you didn't need to build this. If you did build it, cool. Let's build this stuff right here. Let's build this together. I'll just do it again so that you can follow along with me if you want. We're going to start with, what we're going to do is we're going to see how bangs will move depending on how things are geographically placed on your patch or canvas. So let's start with a bang here, a button, which again you can either go into your Object Explorer over here and find button, which is a pain in the butt, or just use the shortcut, which is a B. And then we need what? How many over here? 5? 1, 2, 3, 4, 5. 5 more buttons. 1, 2, 3, 4, 5. Now, we want to actually arrange these in order. And actually, I will touch into this. We'll touch again on this when we go over keeping the patch clean, because this is something you do all the time to make things line up and look pretty in your patch. You can make all of these. You could just by your mouse get them to line up, and it gives you a little guide here that says that's lined up with that. You see that little brown line? Will somebody turn off the lights so we can see this a little bit better? Leave one of them on. Leave these dim lights on. There we go. You can even turn those dim lights up a little bit. Yeah, turn that up a little bit. There we go. That's good. Okay, so you can see when I drag this with my mouse, it'll give you a little guide that says it's lined up with that. So I could do that and line them all up manually. There is a shortcut to do that automatically, and that's Command Y. So if I have all of these selected and I do a Command Y, it'll automatically line up with whichever object that you have selected that's the highest. So like if this is up here and these are all lined up, and I say Command Y, it's going to move them all up to that higher one. No, it's not. It's going to move it to whichever one is the furthest left. I guess I was wrong about that. All right, so let's test this to make sure I'm right. I'll move this one furthest left down, and we'll line all these up. Yeah, okay. Sorry. When you line these up, it will line it based off of whichever one is furthest to the left. Okay, so now these are all the same height. We need 5 messages. Message, whoops. Message, 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 message. The shortcut for a message is M. Again, if you don't know the shortcut for something, you can just spawn a new object by either grabbing the object icon up here and dragging it into your patcher, and then type what you're looking for, message, and things will automatically pop up for you. Or you can go over here into the object browser and try to find it in here. So I don't like doing that. It's a pain. I like to just double click on the screen, which does the same thing as dragging an empty object. You double click on the screen and then put what you're looking for. All right, whatever. I don't need that stuff. All right, so I have my 5 messages, and we're going to type the question mark love capital I do how. And now connect each of these buttons to each of those messages. You may recognize this from one of the tutorials. Now attach all of those messages into the print object. Oh, I'm sorry, I just did that without even saying. Go ahead and make a print object and name it whatever you want. So print, let's just call this order. All right, now send each one of the outputs of these messages into the print order inlet. Okay. Now, make sure all these messages are lined up as well. I don't think it will really matter, but we might as well. So just select them all, do a Command Y to line them up. Okay, and now connect this bang that's on top of all, or this button on top of all the other buttons, and feed it into all of the buttons. So, I think we've tipped our hand based on that we've constructed this sentence backwards from left to right. But what do you think is going to happen when you click the button? Just go ahead and click it if you haven't already. Check your Max window, right? Because that's where all messages that get printed go to. So you can do that. You can go Window, Max Console, or you can do a Command M, and it will show you your messages that have been printed over here. Where did it go? There it is. How do I love thee, right? So as you can see, it goes from right to left. How do I love thee? Let's duplicate all of these. Just grab everything here, or draw a box around everything here, and do a Command D to duplicate. And let's change these boxes to just 1, 2, 3, 4, and 5. What do you think is going to get printed? That's right. 5, 4, 3, 2, 1. Okay. Now, let's reconstruct what I have labeled here as B. So let's go New Object, bang. Actually, here, this will be quicker than rebuilding this whole thing. Just draw a box around 3 of your boxes in the print also over here, like this. Duplicate just those. Drag them down here. Now let's rearrange these so that you have a vertical tiling. Oh, I guess we don't really need these buttons. Let's get rid of the buttons and just send this one button into all 3 of these. Now rearrange these so that 2 is on top of 1 and 3 is on top of 2. Now, to make sure they line up, select them all and do a Command Y. It will automatically decide for you whether you're trying to line things up horizontally or vertically. If you're too vertically stacked, it says, oh, he wants to line these up vertically. It just does it for you. So if I selected all of these, how do you think it's going to line up? What's it going to line up underneath? Is it going to line up underneath the 3, or is it going to line up under that bang? It's going to go under the bang because that's the furthest left and the furthest up. Okay, so go ahead and click this, and you'll notice that what comes out is 1, 2, 3. Did I select more than one thing? No. So it also goes, so it goes from right to left, and it actually also goes from bottom to top. So, oh, I have this wrong here. Not top to bottom, bottom to top. So it's basically the opposite of the way we read in English. We go left to right and from top to bottom. This goes from bottom to top and from right to left. So geographically, if you have things ordered that way, then that's the order that it will trigger messages. This becomes important sometimes when you're working with, when you have an object that's getting sent to more than one place. So say you wanted to write a little patch that's looking for repeating numbers. So you send a number into a select object that's looking for a particular number, and then you send it out. If it goes into what it's testing for before it gets sent out, then it's always going to say it's the same number. If you wanted it, even though the number's not repeating. So if you sent it a 5 and the previous number was a 4, it's still going to say it's the same number because it's doing things in the wrong order, because it's sending it into the test number before it's sending it out. So you have to figure out how things need to be arranged to get the data out in the order that you need. Or you can explicitly set the order, which we'll look at down here in a minute. So we did the vertical one, and we've done the horizontal one. Let's reconstruct this two-tiered thing right here, this number C. So take what we just built right here, this print order, the 1, 2, 3. Let's just duplicate that again and rearrange these numbers so that it goes 1, 2, 3 on the bottom, like that. And do a Command Y to make sure they're all at the same level. And then let's add 3 more messages above that. And actually, let's do, to make this even more clear, let's do an A, B, and C at the top. So, because it goes first from bottom to top and then from right to left, the way that this is going to work is it's going to do the furthest bottom and the furthest right first. Whoops, I don't want to delete all of this. So I want to send this button also into the A, B, and C. And let's line up the A, B, and C as well. Oh, I guess I should have turned on my mouse pose so you can see my keystrokes. Okay. Also, let's line these up vertically. So grab the C and the 3 and do a Command Y, and the B and the 2 and do a Command Y, and the A and the 1 and do a Command Y. That way, everything now is on the same vertical level and the same horizontal level for each of these tiers. So, the first one that's going to come out is the furthest down and the furthest to the right, which is the 3. What's the next one that's going to come out going to be? Actually, it's going to be the next furthest to the right and the next furthest down. So the next furthest to the right is C. So it goes from the right to left first, and then from bottom to top, from right to left. So whichever one has the greatest value of both of those, it's going to go first. So in this case, it's going to be C. So go ahead and just bang this, and let's take a look. It goes C. Wait, I need to clear my messages. So you can clear your messages so that you don't get confused, and do it again. And it goes 3C, 2B, 1A, right? Because it starts with the furthest to the right and the furthest down, then the next furthest down and the furthest to the right, then the next furthest to the right, and so on. So it goes like that. This can get really confusing and really annoying, and I hardly ever write a patch where I rely on the geographic positioning of the buttons. But I just wanted to show you it because it can cause problems for you sometimes. And when you like, why the hell is this not going right? It's usually because you have an order of operations problem. So what you can do is set an explicit order to avoid this. And there's a couple different ways you can do that. You can use the bang bang object, bang bang, which will send more than one bang out of multiple outlets. So you need to tell it how many outlets you want, how many total bangs you want. So let's do bang bang 3. So we get 3 different bangs. Send a button into the bang bang 3. And now if you hover over the outlets for this, it will say this is the first bang output. this is the second, this is bang after the right outlet. And so in this case, it's the second. And this would be the last bang output. So in this case, it's the third. So you could now, if we had the same thing, let's grab all this A, B, C, 1, 2, 3 stuff and duplicate it. Bring it over here. And actually, let's change this bang bang 3 to bang bang 6. And let's make it go 1, 2, 3, A, B, C. So we would just send the first one into the 1, the second one into the 2, the third one into the 3, the fourth into the A, fifth into the B, sixth into the C. Now if we bang this, lock the patcher, and click that, you get a whole bunch. Let me just clear my thing. And now we get it the way we expected it, 1, 2, 3, A, B, C. Or we could have rearranged it to do whatever order we wanted. Now we're not relying on the geographic position. And this is the way I suggest to do things, if you can. There's another thing you can use is trigger. So you could have one, let's move this over here. So you can have one bang or button and then have a trigger object, which you can type out trigger, or you can just put T as a shortcut. And then you tell it what you want to trigger after that. So if we wanted this to just trigger a bunch of bangs, we could say trigger bang, bang, bang. Or we could just say T bang, bang, bang. Or even shorter, we could say T B, B, B. That's another abbreviation, was the word I was looking for a bang. So T, B, B, B will, if you hover over the outlets, it will tell you that the output order 1, this is a bang, output order 2, bang, output order 3, bang. This trigger actually can be whatever, it can trigger whatever you want. So in this case, we're triggering bangs. We could trigger a couple bangs and maybe a symbol like, I don't know, anything. Right? It will output from here. So let's add some bangs here so you can see what's happening. Some buttons, rather. I call buttons bangs all the time, because that's what they do. They make a bang. We have 3 buttons. We're going to attach it to the bangs here. It's doing this, basically, you're going to see them all go at the same time. It's not really at the same time, but it's because it's only separated by 1 computer cycle, which is like even less than 1/100th of a second. But they are going 1, 2, and 3, and we proved that by doing our print messages up here. If I pass this into 2 bangs and a message, and actually here, let's put a message on this last one. And attach it to the right inlet of your message box so that it actually puts the message in the box. What this is going to do is it's going to send the word anything out of this outlet, then it will send a bang out of the middle outlet, and it will also send a bang out of the last outlet, but we're sending that bang into a message, so it gets interpreted as a message instead of a bang, and when it's interpreted as a message, it's literally the word bang. So you see anything, the button lit up, and we got the word bang over here. Also, let's take a look. Let's recreate this over here. So start with a message with a 90 in it. This is showing you how a trigger can trigger various types of data based on the abbreviations that you put in it. T, B, F, and I. What do you think? What's B? We just went over that. What's a B? Bang. What do you think an F might be? Float. Yeah. And so if F's float, what do you think I is? Integer. Exactly. So if we send this 90 in here, then out of the first outlet's going to be an integer, so it should be the same. It should be 90, and it is. Then followed by the next thing that's going to come out is a float value. Now those are convertible datas. You can send an integer into a float object, and all it does is convert it to a float. So if I click that, you'll see that it puts a period after it. That is really important to know. When you see a period after a number value, that means it's treated as a float. And then the third outlet's going to be triggering a bang. Actually, let's not use a button. Let's use the third message so that we can see that that's a bang.
What's the 90?
90 is just, it's another message. It's what we're sending into this trigger object. So the trigger object doesn't care. Well, it depends, but it can't. Depending on how you use it, it doesn't even care about what the value is coming in. This could be a bang, and it just wouldn't output anything here because it never received an integer. But if I'm using these abbreviations of float and integer, what it does is if it sees an integer coming in, it will output the integer here. If you have a float, then it will output the float conversion value here. Let's add one more thing. Let's add just a random word, foo. Right? Now, foo is a symbol. It's not a number. It's not a float, a bang, or an integer. And so then, if we're sending a 90 in there, it's just going to use that as an impulse to send out its trigger. So it just sends out the word foo. It has nothing to do. It doesn't care that this is a 90 coming into it. Because you just told it, when I get an impulse, output this stuff, output this symbol. There's also one other type of abbreviation, and that's symbol, which is an S. So if I had foo and then S, this now is going to be, coming out of this last one, this will be this value, this message interpreted as a symbol. No, maybe it's not. Maybe I'm wrong about that. Yeah, never mind. So this would only output if it received a symbol. So if I sent it a symbol like test, then test gets sent out this outlet here. So in this case, we've used that abbreviation to filter the data and only send it out this outlet if it's a symbol.
This test is a symbol.
Yeah, test is a symbol, right. There's last class we went over the types of values in Max. I'll just reiterate that real quick. There's floats, ints, symbols, and bangs are really the most common types. And then there's also audio data and video data, which are basically matrices. And then there's also OpenGL video textures, which is kind of another type of data that we'll get into. But floats and ints are convertible. If you send a int into a float, all it's going to do is add a period to the end of it. If you send a float into an int, it's going to chop off anything after the decimal point, and it won't round. It will simply chop it off. So if it's 12.9, it's gonna be a 12 at the other end. So if you took, for example, if you took 2.75 plus 1.25, that should equal 4. But if you sent those into a integer boxes, and this was in the tutorial on math, what's going to happen is it just cuts those off. It doesn't round them, and you'll end up with an answer of what did I say? 2. You'll end up with 3 instead of 4. So it's important to, if you're using floats, to use float objects and vice versa. All right. So there's setting an explicit order using triggers or bang bangs. Yes.
I tried putting test also in the 19 message box.
Uh-huh.
Just a space bar and a test. And it resulted in sending out 90 tests into the symbol.
Wait, right here, 90 space test.
Yeah, I thought it would like separate, we just like divide them.
Yeah, no, because this is a symbol. This is 90 tests. So this is a message consisting of this. Now what these are doing, because we've used these shortcuts here, this is saying, okay, we're only wanting to output a float, so I'm just going to take the 90 part of this. This one says I'm only wanting to output an integer, so I'm just going to take the 90 part of this. And then bang doesn't even care, it just sends out a bang. Foo just sends out a foo. Doesn't care what you sent into it. Yeah, so when you have messages that are separated by a space, and this is something we'll go into again later, it's treated as a single message with more than one variable in it. In this case, an integer and a symbol. But they're treated as one message, but with two different elements, right? And those elements can be separated depending on what the object is doing. You could treat this as a symbol just itself by putting a quotation marks around it. That will tell Max that this is a symbol and not an integer. And now it should only come out. It'll say 90 test over here. We didn't get any integers, so those are floats, so those just end up being zeros. Okay. One other way of formatting messages is if you wanted these to come out subsequently, like first it sends a 90, then it sends a test, you can separate them with a comma. Now test comes out here. First 90 comes out. You're still seeing zeros because the 90 would have been in here, but then subsequently 1 millisecond later, it replaces that with the zeros that come out because you hit test. But don't worry about that too much. We'll go back into that later. All right. Recursion, which is where you have something, an output of a process feeding into the input of the same process. It's a bad idea in programming. Why? Well, what happens when I hit this bang? It's going to go from 1 down to 2, up to 3, up to 4, back to 1, back to 2, back to 3, back to 4. It's going to go around and around and around, and it will never stop. It's a runaway feedback loop. And what happens if you were using like Max, an old version of Max, like Max 4, what would happen is it would crash, and it would just crash your program. Max 7 is a lot better at preventing crashes, and when it does crash, it even usually saves your patch for you and says, "Hey, do you want to revert to your changes, or do you want to restore your changes?" But another thing that they've done since Max 5 is they detect these feedback loops and lock them down. So if I click this, what's going to happen is it's going to give me an error, and it says button stack overflow. Outlets are disabled until this message is cleared. And that keeps the program from crashing because it stops, because it was running out of control. So now if I click this again, it's not letting me click it. Nothing is going because nothing will happen until this message is cleared. So I need to clear this message by going over here and hitting the X. Now that message is cleared. So just if you have that happen, if you have your patch just locks down and stops like that, it's probably because you have a feedback loop somewhere, and it will tell you where it is by right here. It says button. And if you double click this, I believe it will highlight the offending object. Yeah. In this case, really it's all of these buttons. But if you had one object, that's just where it happened to start when it detected it. That's where it happened to stop when it detected the runaway feedback loop. But it's pretty close. You know that it's somewhere in this code here. Whenever you get messages or errors, a lot of times there'll be, if there's a link here underlined, you can double click that and it will highlight whatever was causing that error, which can be really helpful for debugging. But sometimes it's not sufficient. If you have too much crap on your screen, it's going to highlight it, and you won't even see it. You're like looking, I didn't see it highlighted. So that's why it's important to keep your patch clean. So let's see. This, you don't really need to do anything here. I guess I could show you a few things. Let's look at, first of all, encapsulate sections into a subpatcher by selecting what you want and typing Shift-Command-E. So say I had this thing over here. Let's just duplicate. Grab some of your code that you've done already and duplicate it and drag it down here. And then make sure that it's still all selected. And actually select everything but the initial bang, say. Okay, leave that unselected. Now do a Shift-Command-E. Then it encapsulates it into a subpatcher where it says P. And then P is a shortcut for patcher or subpatcher. You're going to need to give this subpatcher a name so that you know what it is or what it does, and so that your computer will know one subpatcher from another subpatcher. They all have to have unique names. So in this case, let's call this, just call this P subpatcher. Okay, now double click on the subpatcher. Huh?
How do you
Shift-Command-E. Shift-Command-E. So you can double click on this subpatcher. First lock your patcher or hold down the command key and double click. And this opens up the subpatcher window. And here's all the code that we just put in.
Is that all again how you open the subpatcher?
Yeah, so once you've created the subpatcher right here, simply lock your patch by holding down command and clicking on the canvas, or you can override the unlocking just by holding down command and double clicking on the patcher. Once your patch is locked, just double click on the patcher to open up the subpatch. So I'm clicking right here to open it. And if my patch is unlocked, I either have to first lock the patch and then click on it, or I can just hold down command and click on it. Okay? How did I open it? Okay, so you lock your patch and then double click on the subpatcher and it should open it. Do you have a subpatcher down here? Yeah, oh, try not to select the button. If you did, it's all right. I wanted to show you what it will automatically do is create inlets and outlets for you. In this case, we didn't have anything coming out, so we don't have an outlet. Well, you can or you can't. In this case, I was not, so that you could see that it'll automatically create an inlet for you. Let's grab all this again. This code, let's duplicate this again, drag it down here. And now this time don't select the button and don't select the print, but select everything else. So all this stuff in the middle, but leave the print and the button out of it. And now Shift-Command-E. And now you have, this subpatcher has an inlet and an outlet as well. So let's call this one Subpatcher 2 so that it has a unique name. Well, this is a subpatcher, not an external patcher. We'll go over external patchers in a couple weeks. This one saves just inside this patch. So it's just a way of isolating code in a convenient little object inside your patch. But yes, you can save them externally and they'll save on your hard drive if it's something that you want to use all the time or something like that. So now you can see it's created an inlet for us and an outlet. This is the little icon for an inlet. If you want to make a new one, so say I've created this subpatch and I want to add some functionality to it, I can make a new inlet. So I'm double clicking on the canvas and I'm typing inlet, inlet. And now it's a 2 because it's the next to the left, to the right of where the first inlet was. If I moved this to the left of 1, it's going to reorder, it's going to renumber them. So what that will do is now there's 2 inlets. Let's make another outlet. So just duplicate your outlet over here. Actually, let's spawn it so that you know it. Outlet. Okay? And let's just pass the inlet straight through the outlet. So this just goes straight through this thing. You can close this subpatcher. And now you can see the subpatcher has 2 inlets on it because we added one to it. And that's the one that goes straight through, right? So if I put a message down here and a button up here, it's just going to send a bang through. Yeah, mine isn't either. What the hell? What did I do wrong? No, I shouldn't. I don't know why that didn't work. Well, let's see. Let's send a message through it. What the heck? My outlet is not, my inlet is not going to my outlet for some reason. Let's try this again. Duplicate the outlet. This should just pass whatever data I'm putting in there to the outlet. I don't know why it didn't. I don't know why that's not working. That should have worked. Yours is working? All right, so if I click this, it should do this ABC123 thing in the max window. Oh, I know why, because look, I never cleared my Stack Overflow, so nothing is triggering. There we go. Let's try this again. This should just go straight through, and it does. So if I send a 1 into it, a 1 comes out. What this is going to do is what this did over here, where it will send the ABC123 to the print object. So if I show my max window, which I keep minimizing, then it does the ABC123 thing. Okay? So that's one way you can isolate code. Sure. So you're talking about changing the backgrounds to objects and stuff?
No, just creating like a square of color.
Oh, okay.
So right now I'm trying to keep straight using this.
Right. Yeah, so what you're talking about, I believe, is called a panel. Yeah. So if you just want a colored background area, the object is called panel. Now, it by default gives you this ugly gray, which is the same color as the background to everything. Go into inspector for that. What is wrong with my inspector? I just need to resize it. There we go. And right here under BG fill color, you can change that to a different color. I think by default it wants to do a gradient. Let's see, how do I get it to not do a gradient? It's in here somewhere. Where's gradient? Oh, you're right. Yes. Okay. So in the yeah. Okay. So you could turn the gradient off. You can click on that and go to color fill, and now I can just select a solid color. Or if you wanted it to be gradient, you could set what you want it to go from to. So that's red, and I want it to go to blue. Now it does a red to blue. This is called a panel object. Panel. So you can do this and put it behind things. Now the thing to remember, so that brings up a subject, and that's layering. So right now, by default, objects are just layered in the order that you spawn them. So I made this panel after I made the stuff underneath it, so it's on a higher layer, and so it's obscuring it. If I want this to be in the back, all I have to do is select what I want to move and go to Arrange up here and go to Send to Back. Shift Command B. And now it puts it behind my other objects.
If you get an inspector list, you can go back there and pick that
Include in background. I believe what that does. What does that do? It's kind of I've used that a couple times. I believe. Oh, what that does, I believe, is it makes it so that the patch cords are in front of it. Because okay, so if it's not in include in background. So these patch cords always reside in what's called the background. So even if this is on a lower layer than all of these objects, their patch cords are still not going to be on top of this panel because the patch cords reside in the background and the panel doesn't. So if I have include in background unchecked and then I lock it, you'll see that all the patch cords disappear, because they reside in the background. If I want to see that and I want to see the patch cords on top, then I need to go and say include this panel in the background. And now the patch cords are on top. Okay. So yeah, panels, that can be a way to organize things visually. We were going to go into panels later when we go into actually doing graphical user interfaces. That's where I use panels the most, just to make a cool colored thing, and this section of the program is one color and this section of the program is another color. Automatically resize objects, yes. So this you can resize objects by doing Command J. So like if I make a comment, this is when I most often resize things. It makes this comment a default size, and if I just am having a few letters, the comment is still this huge size, and this is all extra. It's invisible in this case, but it's still kind of annoying. And if it's bigger than your word, you're going to accidentally select it all the time, and it's just doesn't look good either. There's a shortcut you can resize this manually by going down to the edge of it. When your patchers unlock, if you go to the edge of an object, you get this little arrow thing, which is a grow box icon, and you can change the size of it. And it'll even make things vertical if you want, if you make it narrow enough.
Is that just the comment?
No, this is any object. I can grow this box too. If you want to automatically resize it to the length of your message or the length of the text in there, you can do a Command Y. What? Maybe. No, Command J, sorry. Command J. Command Y was for ordering things. Command J. And then it automatically resizes it to the length of your word. I could also do that in the same thing over here. So this print order is stretched out. If I do a Command J, it makes it just the length of the text inside of it. This, sometimes it makes sense to make things artificially wider than you want, just for visual, just to visually make things line up better. So say you had, let's see, what's a good example of this? Where's our trigger thing? Yeah. So say you had something like this code over here. And I'm trying to make this look really good. This is a really simplistic example, but I think you'll get the point. it can be really hard if you have a spaghetti mess of patch cords to figure out where things are going. And sometimes you can rearrange things so that you can make this wider so that all of your patch cords line up vertically. So see how this one's not vertical because I needed more space than for these three objects, then this object is wide. So this third output cord is going in a curve like this. If I drag this wider, I can actually give myself enough room where all of these objects are just directly underneath the output. In this case, it's kind of stupid, but you'll find that doing this can make things line up, that your patch cords don't cross that way, and then it makes it visually easier to understand where things are going. As long as we're talking about patch cords, let's talk about keeping your patch cords untangled, right? So obviously, if I have something like going like this, it can be difficult to tell where everything is going. If you can, try to arrange your patch cords so that they're not crossing each other, right? So now nothing's crossing each other, and I know exactly where each one of those patch cords is going. Other thing you can do is you can create a you can align your patch cords by doing a Command Y. So let's see, what would be here? Let's just grab this again. Grab this test foo, all this crap. Oh, so now I just want to edit my selection. I can hold down Shift and unselect something and reselect and select new things if I wanted to. So now I have all that code selected. I can duplicate it with a Command D. I'm going to drag it over here. Okay. So I have all these patch cords and they're just going all over the place. You can select all of your patch cords. You can select a patch cord by clicking on it. It can be difficult to get your mouse in the right position because the cord is so thin. There is a shortcut to select patch cords, and that's holding down the Option key and then drawing a box. So when you do that, it will select patch cords. It will still select objects as well, but it will select patch cords. So in this case, I want to select just patch cords and not the object. So I'm going to hold down Shift and click on this test to take that out of my selection. Now if I do a Command Y, which was the align shortcut, which works on objects, it also works on patch cords. You get these cool circuit pathways, which can make your cords easier to follow visually. There's another option, and that's called route patch cords. So this is align patch cords, and that's a Command Y. Whatever patch cords you have selected, it'll create this little S bend in it, and you can grab, if you hover over the patch cord, you'll see an arrow, and you can change where that S bend is. So I can say I want this one. This one's confusing where it is. I'm going to have it go down here so that I don't get confused about where it's going. You can also change, in this case, I don't have anything going up. Let's see. Add a message. If you have an object that's higher than the object that's getting sent, so this is coming out here, but it's going up and then down, and you do a Y, Command Y on that, it'll do an entire S curve. On this S curve, I can not only change where this is, I can change what the height and the width of this patch cord is. Right? So you can do this to rearrange or organize your patch cords so that you can follow them. Now, what I suggest doing is arranging your patch cords in a logical manner. And what I mean by that is that if things cross like this, it can be really confusing as to where it's coming from or where it's going. You could have every single patch cord on a different plane, and then it's easier to keep track of where things are going. But it can get difficult if you have so many patch cords just to follow, even if they are all isolated from each other and don't cross, it's just so many lines going everywhere that it's still hard to follow. What I usually do when I'm arranging patch cords is I keep things on the same plane if they're coming from the same place or they're all going to the same place. So let's see. What's a good way to show that? Let's start with an integer down here. Ugh, no margin space. I hate this. In Max 7 and Max 6 and Max 5, actually, they don't give you any extra margin space below where your lowest object is. Wherever your lowest object is, you can't scroll down any further. What I usually do to overcome that is just I make a comment, grab the comment, throw it way down here. Just an empty comment. Now it gives me some margin space where I can scroll past that. All right, so let's start with this int or number box, and we're going to send this into send it into another integer and plus object. And a send object, send test. We'll go over sends in a second. All right, so send this into all of these. If they're all coming from the same place, which in this case they are, they're all coming from this integer. Whoops. And now let's select your patch cords, hold down the Option key and drag, and do a Command Y. It even does this for you automatically. If they're all coming from the same place, it'll put them in the same line like this. And visually, that makes sense to me because all these are coming from the same place and it just branches off, right? What you wouldn't want to do is have, so say this one is also getting sent into this. And now I do a Command Y. That's confusing, right? Because where is this getting sent? You know, if you click on it and highlight it, it will trace it out for you. But if you're just looking at this, this could be getting sent into this test, this send. This could be getting sent into this plus. So this is coming from a different place. So what I usually do is put that on a different level like this. Now I know that this is just going to here. Does that make sense? And if things are crossing, I like to make them cross where there isn't already a curve. So like you can tell that these have nothing to do with each other because it's a straight T-junction and there's no curve to it. Wherever there's a curve, that's because it's split off of a line. Does that make sense? Yes?
Sorry to go back a little bit.
Yeah.
I know you grab, you do command, I think grab, what is the option to grab the different,
Option. Hold down Option and drag to grab
what's the
patch
step
cords.
after that to get them to turn over?
Oh, Command Y. Command Y. So in this case, the Command Y's decision was a bad one for us because it put these on the same line. So I would just then subsequently go and grab this one and drag it down a little bit. That way you know what's going on. So that's aligning patch cords. There's also another way to align, and that's called to route the patch cords. And that's a Shift Command Y. So unlock your patcher, grab the patch cords. There we go. So that's an Option drag. And do a Shift Command Y. Shift Command Y. Oh, that's not a very good. What this is going to do is it's going to route things around objects that are in the way. So let's put an object in the way. Let's put right in the middle of this, let's just make a message. And just put it in the middle of these patch cords. Okay. Now select all the patch cords again. Option, drag. Unselect anything that's not a patch cord by holding down Shift and clicking on it. Now do a Shift Command Y. And you'll see that it's routed the patch cords around that object that's in the way. Does that make sense? This can make things easier for you by making sure that because if patch cords go behind an object, it can hide where it's going or where it's coming from. So this is going around it. I don't use this that much because it can get really unwieldy. It can make some crazy squiggles when you have objects all over the place to try to route it around. I usually just move my objects to make things line up in an orderly fashion, right? And then, of course, we went over subpatchers. I want you to know that subpatchers are not just a way for you to hide messy code, right? Yes, it's put all this code in here, and I could have crazy, terrible lines like this, and I don't see them. But that doesn't help me when I need to go debug it, right? And it doesn't help me as an instructor know what's wrong with your patch when you turn in something that doesn't work correctly, right? So you got to keep your patches clean and organized. And we'll just be checking in on that as we go along. It will become a habit to you after a while. Let's see. Encapsulate, resize, align, route. Oh, sends and receives. So, one other thing you can do is instead of drawing a patch cord between objects, you can send it into a send object. And then you'll have a corresponding receive object somewhere else where the patch cord comes back out. And that's kind of like a wireless way of sending data. Not literally wireless, but graphically wireless. So I usually will do this anytime I'm sending a value from lower down in the patch to higher up in the patch, because it's really annoying. So if I'm sending this output from here and I needed to send it into the trigger way up here, I got a big ugly line going right through the middle of my patch. And it looks terrible. And it's confusing as to where it's coming from or where it's going to. So the better way to do that is to simply send it into a send object. Oh, whoops, not message, object. New object, which you can double click or hit an N or drag the object icon. And go to send. And then give it a name, because it has to have a corresponding named receive object. So let's call this whatever. All right. You can also, instead of typing out the word send, you can just put an S. So I did S test. Now, yeah, no, in this case it's an S. S means send because it's the first thing in this object. If I was using a different object that might work with symbols, it would understand an S as symbol. But in this case, this is an object called S, which is just an abbreviation for send. Yeah. So S test, right? And then we just need the corresponding receive object. And what I usually do to make sure that I don't type it wrong, because if I spell it wrong, it won't come out and it'll break my patch. I usually just duplicate my send and then rename it as a receive. So I duplicate the send and just highlight the word send and change that to receive. Or what do you think the shortcut is? That's right. So I'm going to duplicate this test and make it into an R test. Okay, so now let's send some data into these two sends. Hello, world. Actually, just say hello. I'm going to send it into both of those, and they should come out over here. Let's add some messages over here. And again, I'm going into the right inlet of this message because that's the inlet that will, if you hover over it, it tells you set the message without output. It also is what puts the message in the box so that you can see it. If I had it on the left output, then you wouldn't see it. It would just trigger the message as if it was a bang. Okay, so now I have that. If I lock my patcher and click on this hello, it will come out the receive. So I could, if I needed to send this number up here, I could just have a send. Whoops, I keep doing messages instead of objects. Send test 2, right? Make sure that you give things unique names, or else it will get sent to the same receive. You can have more than one send with the same name. It's just all going to go to the same receive. You can have more than one receive with the same name. It's just going to always receive things going to that send symbol. So just let's look at that again. Just duplicate receive whatever and make a new message. And now this will get sent to that one as well, right? So I can have as many sends and receives of the same name, but if I want them to have independent channels, I'll need to give them an independent or a unique name. So here's send test2. I'm going to send this, actually let's do this outlet. This outlet to test2. I'm going to duplicate that, and I'm going to take it up here. And let's see, it's going to be whatever we send in, so that's going to be like a bang or something. We'll just attach it to any of these up here. Receive. Test2. And now attach that to this bang. And now clicking this down here, this one will trigger this stuff up there. And you saw the tail end of that bang lit up. Because I received, I'm sending this into a send down here, send test2, right? So this is our little sub patch that we made. This outlet went straight through, right? Remember, it just goes straight through. Exactly. So it's sending a bang or a 1 or whatever to this test2 send object, which is getting received up here, which is triggering this bang on this stuff, which is triggering the max window to print out how do I love thee. But I keep resizing it. There we go. See, so it did trigger how do I love thee. So right here, this original two, this hello message was getting sent into these two different two different send objects, which are being received by these two different.
Right. So what are the containers that are receiving?
These? It's just a message. Yeah. Anytime you see a gray box with rounded corners, it's a message. Yours isn't sending? You probably typed something wrong. Let me take a look. Yeah. Oh, you just are going into the wrong inlet of your box. Like I said, you have to go into the left inlet, a right inlet to be able to see it.
Oh, the color? Yeah. I'm trying to make it so like, yeah, the color stops moving. The color stops moving. Like if I send it to back, like if I want to send these. Yeah, like
Oh, try including it in background. Maybe that'll make that stop. Maybe that's another function of including background. No, it is. Yeah. Well, yeah. Okay. So yeah, you're right. When you have that's one reason why what I usually do. We'll go into this. We'll go into there's a mode called presentation mode, which is like putting your patcher in a mode for operating it and not editing it. And what you can do is you can have objects change their size and change their location in presentation mode, and not that's different than editing mode. And what I usually do is I just have my panels line up in presentation mode, and then when I'm in editing mode, they're like really small, stuck in a corner somewhere like this. And then when I go into presentation, it moves it over. But yeah, it's going to always get in your way if you have it behind something for selecting and moving. But we'll go over presentation mode, I believe, in 2 weeks. So that's about it on this. We can get started on the slot machine with the amount of time that we have left. Obviously, we're just going to get started on it. Does anybody have any questions on this before I move on? Cool.
I was doing this spot for my send with the send.
It probably is that you put it into the wrong inlet as a message that's receiving it. So if you go into the right, so if you go into the right inlet, well, first of all, that should have been an object and not a message. Yeah.
Gotcha.
Yeah, so that was a print.
That's a good message.
Yeah. But as long as if something is receiving, if it's going into the right inlet of your message, it will be displayed. If it isn't, if it's going into the left inlet, it'll actually just be ignored by the message, and it'll treat it as a bang and not as a message.
So it has to go the right inlet.
The right inlet of a message, correct? Which is what displays the message. The left inlet is for triggering a message to actually activate. If you send a message into the left inlet of another message, it doesn't care what the message was that you sent into it. It just treats it as a bang, and it sends out whatever was inside the message box.
That's why that message is sent back.
Yeah. Well, a bang will, if you send a bang into the message box will be treated as a bang. So actually, in this case, you wanted it on the right inlet because you already had a message in those boxes. Sorry, not right inlet, the left inlet. And you wanted to actually trigger that message, not set the message. Does that make sense?
Yeah. So then the bang is triggering the message.
Exactly, and those messages are what's already in there, the 3, the 2, and the 1. Yeah. Any other questions? Any other things that aren't working on you guys' patches? All right, cool. Question?
There's bubble thing, there's no stuff like that. I think on the address you know,
Which bubble? What?
that's,
Oh, the bubble point?
yeah.
That should be working. Try it again. All right. Oh, you have $1 instead of $1.
Oh.
Headache. All right. So, with the time that we have left, and this is probably the way a lot of classes go. I have an agenda for it, but we usually don't get through the entire agenda and things stack up. But that's all right. We have plenty of space in the itinerary to deal with that kind of stuff. And if things get backed up too much, I'll just cut certain sections that we don't really need to look at. Okay. So slot machine. We're gonna make a slot machine. First thing, what we're gonna do with the slot machine is we're gonna use coding to kind of represent the mechanical processes that go on inside of a slot machine, or at least inside of an old mechanical slot machine. Nowadays, a slot machine, even if it does have mechanical wheels, it's not really a mechanical process. It's a computer picking a random number and then moving the mechanical wheels to fool you into thinking there's a mechanical process. But we're gonna emulate an actual mechanical process with numbers and math in Max. And we're gonna use this as an exercise to look at math objects and also look at logic operators, greater than, less than, equal to, Boolean operators, that kind of stuff. You'll use that stuff in Max all the time when you need the computer to make a decision, saying, is this greater than this? Has this number been displayed yet? You'll use those kind of operators. But let's start just by thinking about what a slot machine game is. Like, what are the steps of a slot machine game? Yeah, exactly. You go to the slot machine, you put your money in, you pull the handle, the wheels spin, then one wheel stops, then the second wheel stops, then the third wheel stops, and then the the machine decides whether you won or not. If you didn't win, it takes your money. If you did win, then it gives you a payout based on whatever the value of the wheels that's being displayed. So the first thing we need to do is we need to have a system that's going to have some wheels that are spinning, right? And we need to have a system that's going to be able to have those wheels spin and have those wheels stop at a particular points. So that's the first thing we're going to build. And in order to drive this, the easiest way to do that is to drive it with some type of counting mechanism or counter mechanism, right? There's two ways. There's two general ways in which a slot machine works. And normally I have my little, and I had it in Isadora, I have a little visual aid of a slot machine, and I actually have it torn apart so you can see the inside. I've misplaced it. I don't know what happened to it, but it didn't work that well anyway. But I can explain what happens. So when you pull the handle down, what happens is there's a thing called a kicker plate. So you're generating some tension in a spring, and when that spring gets to the end, it kicks this kicker plate that starts all the wheels spinning. And because of friction forces and other things, maybe there's a mechanical thing in some of the older slot machines, those wheels will spin at different rates. Some will spin sometimes it will spin a little bit faster, and sometimes it will spin a little bit slower. And then there's a stopper fork that has 3 different tines on it that move. So these wheels are spinning, and these stopper forks come up slowly, and this tine hits the first wheel and stops it from moving. Then it keeps going. Each tine is a little bit shorter than the other one. So this one stops it first. Then this one's the next highest up and stops the second wheel, and this one stops the third wheel. So you actually, the stopping of them is predictable. It stops this one after this many seconds. It stops this one after this many seconds. It stops the third one after that many seconds. But what the randomness is created by the different velocities of the wheel, because the first wheel may be spinning at one rate the first time you kick it, and it'll be spinning at a slightly different rate the next time. So you can't really predict where it's going to stop the next time you pull the handle down. So that's one method, where basically you have random velocities of the wheels and a fixed stopping mechanism. That one you could do in code, but an easier way to do it is to actually do it the opposite way, where you have a constant velocity of the wheels and a randomized stopping mechanism. So that's what we're going to do. We're going to use this. We're going to create a clock. The clock's going to drive these number counters, which will represent our wheels, and then it will stop those at certain times, and then we'll add random numbers to those certain times to make it a random time that it stops. That will add randomness to the wheels. So let's start with making a clock. So let's see. So save your patch 2.1. Make a new patch. New patcher. File save as. I like to save and name my patches right off the bat so that I don't accidentally save over an old patch. Especially if I'm starting from an old patch and changing it, I'll immediately rename it so that way I can keep the old patch and don't accidentally save over it. So we're going to class 2.2. Okay. Let's start with a clock. Now, the fundamental clock object that you'll use in Max is metro. It stands for metronome. And just like a metronome, what a metro does is it creates bangs at a given rhythm. So start with a metro 50. And what this is going to do, if we have a toggle up here, so a 1 will turn on the metro, a bang will also turn on the metro. But in this case, we're going to use a 1. A 1 will turn on the metro, and a 0 will turn it off. A toggle object creates a 1 or a 0 based on whether it's toggling. You can take a look at that real quick by sending this into the right inlet of a message. If I click this toggle, whoops, without holding down the option, you hold down Command to overwrite your thing. Option clicking something opens up the help file for it, and I often will be holding down the wrong button and open up help files inadvertently. Anyway, if I click this, you can see it's sent a 1. When it's off, it sends a 0. Right? So that will turn this metro on and off. Let's put a bang down here so we can see the pulses coming out of the metro. So this is banging every 50 milliseconds. And we can use that. So what that means is if it's sending it every 50 milliseconds, and there are 1,000 milliseconds in a second, that means it's sending out how many bangs a second? Anybody really good at math?
20.
Exactly. Good job. I would never have gotten that if I didn't know it already. Okay, so if we take this Metro 50 and we divide and we have it go to a counter, and then we divide the output of the counter by 20, we can have that be converted to how many seconds have passed. So if there's if there's 20 milliseconds if there's 20 bangs in a second, and we want this counter to go up to 60 seconds and then start over again, what would I want to count up to?
0.
You're counting from 0 to 20 times 60. So 20 times 60 is 1,200, exactly. So counter is the object. And now we need to give this counter some arguments to tell it how to count. If we just left it as counter without any arguments, it's going to count. It's going to start from 0 and it's going to count up forever, never ending. We want it to actually roll over at once it gets to 1,200. So we want to say counter 1,200, which is the maximum number. So the arguments in a counter object are actually dependent on how many, what they mean is dependent on how many arguments you have there. If you only have one argument, then it's what it counts up to, and then it will start over again. If you have two arguments, it will be what it starts at and what it counts up to. If you have 3 arguments, the first argument is the mode of it, whether it's going to be counting up or doing a palindrome count or counting backwards. And then the second one would be what it starts at, and the third one would be what it's ending at. We just need it to count up to 1,200, so we're going to leave it as counter 1,200.
And then stop at 1200.
It won't stop. It'll just roll back over to 0. So attach those, and let's send this into an integer number box, and you can see it's counting up. It'll take a full minute before it gets to 1,200. So now what we need to do, if we want to get this to output seconds, we just take this value, and there's 20 bangs to a second, so divided by 20. Divide, whoops, right here, divide the / 20. Okay. Now make another number box underneath there, and this will be how many seconds have elapsed. 40, 41, 42, 43. That's about a second. So mine's already up to 48. You'll see it should roll over to 0 in a second. 7, 8, 9, 0. There you go. So that means a whole minute has elapsed. Now if we want to get, so this is seconds. So let's label this right now. Comment seconds. Command J resizes it. Okay. Now say we wanted to get tenths of a second as well off of this clock. Let's see, what would you do for that? Well, in my example, I guess there's probably a couple different ways you could do it, but I think the easiest with the least amount of objects is actually use a modulus. Modulus will look at a number. So if you do, and the symbol for a modulus is a %sign, and then you need to give it a value, which is telling it what what operand you're using to get the modulus of. And in this case, again, we're using 20. So what this is going to do is if you sent a 20 into this, it would send a 0 out, meaning, because it's like you're dividing by this number and then giving me the remainder. So if I sent a 20 into this, it would send a 0 out. If I sent a 21, it would send a 1 out, right? If I sent a 41, it would also send a 1 out, because it's only giving you remainders, not the whole, not the multiples. So this is a way of taking a number that's counting up to a high value and having it roll through a set of values. right? So in this case, this is attach this to this modulus, and this would be, let's see, so this is actually a 20th of a second. A 20th of a second, because there's 20 of these in a second, right? That's not a very useful fraction for us. What's more useful is a 10th of a second. So let's take this value and divide it by 2. Divide by 2. And send that into another number box. And now these are tenths of a second.
Is there any way you could explain modulus one more time?
Yeah, so modulus, what it does is it does a division between the number that you're inputting and this, whatever this argument is, the operand. So in this case, it's taking this 700 or 800, whatever this number is, dividing it by 20, and then returning the remainder. So I don't know, I haven't done long division for a really long time, but I do remember that what happens is you have how many whole times the number goes into that number, and then you're left over with a remainder. So if you're dividing 21 by 20, you would get 1 and 1 remainder, 1/20th of a remainder, right? So that would spit out a 1, right? And so what we're using that for to give us the tenths of a second. All right, so now we've created a clock that gives us seconds and tenths of a second. We're going to use this to drive some wheels. And our wheels are just going to be actually counters with number boxes attached to them. Grab this section of code right here, the counter 1200 and the number box below it. Duplicate that, drag it over here. Change the 1200. We just want this wheel to go single-digit numbers. So it's going to count from 0 up to the largest single digit, which is 9. So counter 9. Now, if you hover over the first input of this counter, it says int bang are counted, sets the counter value. So this will count how many bangs it receives, and that's what we're doing up here with this metro. It'll also count integers received. It doesn't care what the number is, it just treats it as if it was a bang. And we're just going to save it, to not have to use more than one metro, we're going to send the counter output from this counter into the counter input of the counter driving the wheels. So take this counter 1200 and send it into this counter 9, like that. And you can see it drives it fine. In fact, let's grab this section of the code and drag it more toward the middle, so that, because this is going to be the main metro that drives everything in the program. Okay. Now let's duplicate this 2 more times so that we get 2 more wheels. And send the counter into the counter output from up at the top into each of those other counters that you just made. Okay, so now we got wheels that are spinning. We need to now, so that's the first part of the program. We got a way to turn it, to start it, right? Because if you turn this on or turn this off, it will stop. If you turn it on, it'll start spinning. We have spinning wheels. Now we just need to add the mechanism that stops those wheels. So these wheels are being fed by impulses, or numbers in this case, that are coming into this first inlet of the counter. We can cut that flow of information off with an object called a gate. It's like a gate. If the gate is closed, you don't get through. If the gate is open, you get through. You'll use gates a lot in Macs to do logic or to just control the flow of data. So let's add a gate object. Now a gate, you can add a parameter to this gate, or an argument rather, to this gate that will specify how many outlets the gate has. So if I had gate 3, it has 3 outlets. The first inlet here is actually not what you send the data through. It's what controls the gate, whether it's open and which outlet is open. The right inlet is what the message that's going through the gate is. So by default, the gate is closed right now, and if you hover over these outlets, it will say output 1 currently closed, output 2 currently closed, output 3 currently closed. If I sent a 1 to this gate, it would open outlet 1. If I sent a 0, it will close all the outlets. If I send a 2, it'll open outlet 2 and close whatever might have been open before. If I send a 3, so on. It will open outlet 3 and close the other 2. So you can use gates to actually route information to only one place, but of multiple different options. So if you want, you need to send this value here, but in a second, after you've done some calculations on it, you need to send the same value over here. You can send it through a gate and send a number into that gate to change where it's going. In this case, we're just going to use it to either let information through or keep information from going through. So we don't need more than one outlet. We just need one outlet. So we could say gate 1 or just gate, because by default it gives you one outlet. So I'm just going to actually just say gate. Okay? So let's delete these connections between your upper counter and your wheel counters. Let's get 3 gates, 1 for each counter. And attach the outputs of those gates to the first input of those counters. And then attach the output of the upper counter next to your metro to the right inlets, which is where the gate incoming messages need to go, of each of those gates. Okay. Now let's just put what will open this gate will be a 1, and what will close it will be a 0. We already used an object that gives a 1 and a 0. What was that? The toggle, yeah. So let's put a toggle on each one of these gates. Okay. So right now the gates are closed. These wheels are not spinning. But if I put an X in these toggles, they'll start spinning because it's opened the gate and the impulses are getting through. Okay? So we'll go into the actual logic and math calculations onto how to close these gates sequentially next week. We're out of time now. But we got the beginning of this program going, and we have a clock, which we'll use a little bit more later, and we have these gates, which will stop the wheels. Right now I can do it manually. Oh my God, I won! But we'll create a system next week to do this automatically.
Do slot machines have 0?
Slot machines don't even have numbers. They have like 7s, but they have symbols and cherries and stuff. And actually what we'll probably end up doing if we get to it is we'll have it, when we get into actually loading and displaying graphics, we can use these numbers to select particular pictures, like we did in Isadora when we had a slot machine. Yeah, this number could be like the 3rd position in a list of different pictures to display, right? So if you had 9 different pictures loaded, this could be the 3rd one.
I'm just saying, so do we need to specify so it starts from 1 and it comes to 9? Because right now it's coming from 0.
Right. No, well, we're going to have it from 0 to 9 in our patch, yeah. So that there's 10 different positions on each wheel.
I remember the tutorials, there was something that like resynced, and maybe it was last week you showed us so that I could stop all of the numbers and then start them all again at the same time.
Yeah, that was in the tutorials. They had that, and we'll add that functionality next week. We're going to use a trigger that will reset all of the counters to 0 and before this metro starts rolling. Yeah.
And then how do the counter 9s? How do those get off sync?
Off sync just because we didn't. We started them at different times.
Yeah.
So now if I save this and I close it and reopen it, or I can just do this. Actually, would do the same thing. Grab all this code, delete it, and then undo. That starts them all. And now open these gates before you start the metro. So basically deleting it and then undoing respawned all those objects.
Respawn, that's what
Yeah, and now I can just start these and they should all roll exactly the same. And if I turn these off, they all have the same number, right? We're gonna create the system that'll add randomness to this next class. All right.
You could also just do it by starting with
Yeah, we could start them at different times. Yeah, but that's not usually the way. That's not the way a slot machine works. When you pull it, all the wheels start spinning. But yeah, you could do it that way. You can design it. You can design a program any way you want.
like the first, like level 1, 2, 3.
Yeah, that could do it that way too. Yeah.
Oh, no, just leave this here again.
Any questions? You guys are free to go.
Is there any homework? Besides
No, yeah, just the homework is just finish up tutorials 1 through 8 if you haven't already. Seem like you're keeping up pretty well.
Oh yeah, I'm taking maps.
Oh, cool.
Yeah, I was able to at least keep up with you guys.
Yeah, that's great.
And I've got
Those are all of them.
You're all of us.
Yeah, I am. I'm saying something else.
But I know you
Well, I sent you back just yesterday.
Yeah, okay. I had to check it.
Yeah, I sent it back to you. Yeah, I said in my email that I sent you. I was like, I don't know how your email falls on the radar. Just did.
Don't worry about that at all.
Yeah,
I'm just
I'm not gonna hold your
excited that I didn't come too late, so I still could catch up with you guys.
Yeah, it's totally
And
fine.
then, yeah, I'm trying to put together my audio video showing you new ways I can connect it to. Is this an appropriate class?
Yeah,
It's like
definitely.
it's really open and just trying to keep
Yeah, it's total. I use it for syncing audio or generating visuals from audio data or that kind of stuff.
When I got to the school, I was like, I saw somebody doing that. I saw it was sending DMX.
Mm-hmm.
It was audio
Emails, yeah.
DMX into
Like a lighting board?
3 LED park.
Nice.
And it was
What's up,
up
Basu?
Yeah.
Okay, to get to the tutorials, where do I go?
Oh, right. So go to help
Even though
and go to reference. And then if you're not in the right place, if you're in some other thing, you want to get back to the screen by clicking on the house button. Because it might just show you what was already there.
So I just go to
Now scroll down here and go to start with Max tutorial.
Okay, so just do that.
Yeah, and then do 1 through 8, which are through keyboard mouse drawing. Yeah, keyboard and mouse input. That's the input. Yeah.
All right, thanks.
Yeah. See you next week.
I saved all my lessons somewhere weird on the
You should make a nice.
Yeah.
I have a folder. I saved it to Max Tech, which is like the folder that I took those tutorials into be stored in. But
Oh,
I
right.
can't for the life of me find it anymore.
You know what? I think those tutorials are saved inside the Max application. So go to your Max app.
So I must have saved.
It might have saved there. It's possible to save there. Go to the applications. Find Max 7. Right click on it and say Show Package Contents and Contents and Mac OS, I believe. No, Resources. Sorry, Resources. Yeah. See, is it in examples? Maybe it's in examples. And is there? Do you know what you saved it? Let's just do a search for it.
Max Tech. I couldn't. I was searching
Did you try this guy? That guy can give you. No, this one up here. Try that one. Yeah.
I feel like you have it. I feel like this would.
Yeah, it's got to be in there somewhere.
Yeah.
I think that's where the things are stored. Because the applications are actually just like a hidden directory structure, and you can get to
Yeah.
it by doing that show package contents.
I had never done that.
Also, one last question.
Yeah.
How heavy is the homework load for this class?
It's not too heavy.
Mostly in class and then fine tuning.
Well, you'll have homework. It's laid. The homework that you have is laid out in the syllabus. But here's the major list of assignments. It's the slot machine, which again, this one is mostly in class. the GUI player will get started in class. We'll do like one channel of it, and you'll have to be able to expand that out to 4 channels. Then this kind of stuff, we'll look at it in class, and then you'll have some extra work that you'll have to do at home. Right.
I'm also excited because I'm excited this class even exists. I didn't even know there.